Hello everyone, I am Kalai Selvi, Assistant Professor, CSE Department, RMD Engineering College. The subject code is 22CS201 Data Structures Theory Course with Laboratory Component. Second semester, Unit 2. Now we are going to see stack using linked list implementation. So stack is one of a linear data structure following the principle of last in first out. So the item which is added at last will be emitted first. Now using linked list, we are going to implement stack data structure. So it is a conceptual model of a top variable which is holding the topmost element in the stack. So now we are going to implement this stack in a linked list model. So here the top will be holding the topmost variable. So that will be the head pointer. So the top will be pointing to the next. So the top will be the first, here will be the first node in the stack, and value will be the 5, and the top is holding the next items. So the node structure for the stack will be the data part and the link part. Link will hold the link for the next pointer. So the data structure which we are following to create a node is a singly linked list. Now the stack head structure will be holding the count of the number of nodes in the list, and the top variable will have the next pointer for the first element. That means the topmost element in the stack. So first we have an empty stack. So we are using create function. We have created a empty stack. The count value will be 0 and the top will be null. That means it is not containing any value. So just we have initialized a stack. So using the push function. So the stack will have two functions, push and pop. The push function will add an item into the stack. Pop function will delete the topmost items from the stack. So using push function, I'm adding an item in the stack. So the count value is incremented from 0 to 1, and the data which I'm going to add it is green. Now in the stack, I'm going to add the data green. Now the top pointer will be pointing to the first next node. So the data after creating the node, we will be creating the connection between the head node and the next node using the top pointer, which will give the connection. And next I'm going to add one more data in the stack. So now the data is blue. So I've created the data part and the link part. So now the link actually connected to the green node. So the connection between the top and the green will be disconnected, and I'm creating the top connection to the new link blue, and the blue's next will be next link will be connected to green. So this will be the coding part for push function. So first, this is a algorithm for the creating a stack. So now I will create an empty stack, allocate the memory for the head structure, and setting 0 to the count variable and top to null. So using this algorithm, I created a stack. Now I'm using a push function. So push function in the stack will have the parameters, the stack memory location, and the data part, which I'm going to add into a stack. So allocate a new node. Now you will be creating a new node following the data structure. Like it will have a data part and the next pointer, and the data part will be holding the data which you are going to add into the stack, and the next pointer will be connected to the current top node, will be connected to the second node, and a new node will be connected to the top. Then that stack count will be incremented. So initially, here in this example, here I am creating a new node. Data part is red, and the link first I have initialized with null value. So P new is my new node, which I'm going to add into the stack. So already the stack containing some values, green and blue. So the count value is 2, and the top is connected to the blue. So if I'm going to add the P new here, then the top will be connected to the P new. So now I will create a connection to the top. Next will be next part, that is the top pointer will be pointing from blue to red, and red next link will be connected to blue. This will how the push function in the stack works. Next we are going to see pop function in the stack. So the work of the pop function is to eliminate the topmost item in the stack. So this is an example of a stack. Here the total number of items in the stack, so the count is 3. The top value is pointing to the first element in the stack. So as per the principle of stack, last in first out, the last element which is added in the stack, that will be eliminated first. So the top will be holding the first element, last element. So red will be deleted. So to delete the item, deleting the node red, what we will doing is we'll change the pointer from top will pointing from red to pointing to blue. So we will be disconnect this connection and will be free this memory. This is the corresponding pseudocode for pop stack. So the stack will be, the parameters will be the stack which we are going, memory address of the stack. If the stack is empty, we can't be able to delete an item, then the it will return false. Else the data which you're going to remove will be in the top of the stack, and we're making the connection to the second node from the top of the stack, and the stack count will be decremented, and after finishing the pop function will be terminated. Next, stack top function. So it will return the topmost element in the stack. If the stack is empty, it will return false value. Otherwise, it will return the top value, top data part value in the stack. Empty stack. If the stack count is 0, then there is no item in the stack. So it will return false. I mean, if it is an empty stack, it returns true. Otherwise, it returns false. Full stack. If the memory, if you are sending a stack memory location, and if the memory is not available, it returns true, else it returns false. So stack count. So the count variable will count. Stack count variable will count the total number of nodes in the stack. So destroy stack is to delete the memory allocated by the release all the nodes back to the dynamic memory. Thank you.